Welcome back. In this video, we are going to perform the data exploration and the univariate analysis basically on the dataset and the problem statement that we discussed in the last video. So here is the complete problem statement. Again, we have a regression problem and this is the Chennai house price prediction problem. We already discussed about the different variables that we have here, and we have divided the variables in three subcategories: house features, surrounding and locality related features, which talk about the locality of where the house is located, and the house sale price and commission related features. So let's start with loading the dataset, and we'll first load the required libraries, which is pandas and numpy here, and then we'll load matplotlib, which is used to create the plots. We have a command %matplotlib inline, which is used to make sure that the plots are seen within the Jupyter notebook itself. So let's load that. Now we are going to load our dataset, which is Chennai house price prediction dataset. And if you print the tf.shape, it will give you the shape of the dataset. So here we have 7,100 rows and 19 columns. Now let's look at the head of the dataset. So here are the first 5 rows for the dataset. We have the same variables that we discussed, and this is a unique ID, and these are the variables that we discussed. So let's start with data exploration, and we'll first create a summary using the describe function. We have dataframe.describe here, which gives us the count, the mean, standard deviation, and minimum maximum value, and the values for different quartiles. So you can see that we have all the values here. Now, first of all, we have the count here for each of the variables. So we can see 7,109 for the interior square feet variable. And this is exactly the shape of the dataset. So here we have 7109, and this is true for all the variables. But if you notice here, we have 5 values less, and in this case we have 1 value less. Again, here you can see about 40 values missing. So this number basically can be used to find out the number of missing values in your variables. Then we have the standard deviation, which can give you a rough idea about the variance of the variables you have. And it can also be used to find out the range of the variables. So let's say the standard deviation here is almost 0.4 and here it's 0.8, and we can clearly see that the minimum and maximum value here is 1 and 4. While in this case we have a very high standard deviation value, and we can see that the range of the values is also very large, from 500 as minimum to 2500 as the maximum value in this variable. Right, so there are some basic inferences that you can make. Additionally, you can use the 75th percentile value and the max value to find out the presence of outliers in the data or in this particular variable. So if there is a very huge difference, like we can clearly see there's a huge difference in this case. So we can see that there are a few outliers in the variable sales price. But if you notice, all of these variables are continuous. So describe function right now has given us a summary of all the continuous variables in the dataset. So let's go ahead and use a parameter include is equals to all, which will show us the summary for all the variables in the dataset, irrespective of the variables are continuous or categorical. So apart from the continuous variable, you can see that we have the categorical variables also here, which is the ID and the area. And it gives us the count again, which is used to find if there are any missing values in the dataset. Then it gives us the unique count. So you can see that the total count is also 7,109 and unique is also 7,109 in this case. So we can say that each row has a unique ID. While in this case of area, we have 17 different values, which means that multiple rows can belong to a same area, and which sounds about right. Then we have the top value, frequency, and so on. So these are the categorical variables here. And now if you notice, the mean, standard deviation values for the categorical variables are filled with nans. And for continuous variables, we don't have any unique and top and frequency values. Right, so if we want to look at these values individually, so instead of using count to find out the missing values, if I want to find out the missing values for each variable separately, we can use the .isNull function here. So when we use df.isNull, it will only give me if there is a missing value or not. So it will give me a result something like this, which shows true and false against each variable and each row. Instead, when I use .sum with it, it will give me the count of missing values in each of the features that I have. So we have 3 features with missing values: bedrooms, bathrooms, and the overall quality score. Right, so we can also check the data types for each of the variables in the dataset. We have ID given as object, area again given as object, which clearly shows that these are two categorical variables. And then we have distance from main road and interior square feet area as integers, so we can see that these are continuous variables. Similarly, you can find out which variable is categorical and continuous based on the data types. Now let's put this in the form of a summary. So I have created a new data frame which is called temp, and in this data frame I'm storing the data types, the number of null values for the variable, and the unique count. So when I print this, I will get against each of the variable the data type of the variable, the count, and the unique count. Now if you see that we have the bedrooms and bathrooms as float, which means these sounds like continuous variables, but we can see that the unique count is only 4 and 2 and 5 here. Let's look at what are the values we have in these features. So if I just create a new cell, and now we want to see what are the values under, let's say, n bedrooms. So these values are 1.0, 2.0, and these are float values. So we can change this to categorical or integer column because float doesn't fit in with the number of bathrooms, right? So we'll have to change the data type for this variable under the data manipulation part. And now this table gives us a brief summary of what are the missing values. So we need to impute the missing values in 3 variables, and this is the unique count and the data types. So now this was an overall view of the dataset that we had. Let's now pick up one variable at a time and explore that. So that will fall under the univariate analysis. We'll take up the target variable, which is sales price. So let's plot a histogram to have a look at the distribution for the sales price. And here it is. So we have used plt.xlabel to specify the title for x-axis, which is sales, and I've not changed the title for y-axis. It remains frequency. You can use the same syntax plt.ylabel to change the title at the y-axis. Now if you look at this plot, we can see that it is slightly right skewed. So this part right here looks like a perfect normal curve, and we can see that we have a few outliers on the right side. Now let's say if I want to look only at the rows which have the sales values less than this, which is less than 2 crores, let's just put a threshold here. So I'm going to use df.lock, which is basically locate all the rows which have a sales price value less than this. And once we have that, which is basically a subset of data frame, we'll plot this and we'll again use plot.hist. So now if you see, this looks like a perfect normal distribution right here, right? And here we can notice that it is slightly right skewed. Similarly, if we try another continuous variable, so we have another variable which is interior square feet area of the house. I'm again using the histogram plot here, and we can notice that there are maximum number of houses which have area either between 750 to 1250 or 1500 to 2000 square feet. So this looks like the standard size for a house, and there are very few number of houses which have the area greater than 2000 square feet or less than 750 square feet. So this is the distribution for the variable interior square feet. Now as an exercise, I would want you to take up other continuous variables, like we would have the commission for each of the houses, and we would also have the distance from the main road as another continuous variable. So take up those variables and plot a histogram and see what are the inferences you can generate from those plots. Now moving on, let's check a few of the categorical variables in the dataset. So we'll start with the number of bedrooms. So we can see that there are about 3,700 houses with only 1 bedroom and 2,300 with 2 bedroom and so on. But these counts do not give us a lot of information. So instead of directly using value counts, what we can do is divide these numbers with the total length of the data frame. So this will basically give you the percentage. And if you want the exact percentage, you can also multiply it by 100. And we can see that we have 53% of the houses with 1 bedroom, now 33% with 2, almost 10% with 3 bedrooms, and about 3.5% with 4 bedrooms. So this is much more intuitive than just having the numbers here, right? Now let's take up another variable. We have n rooms. We can again generate the value counts, and this will give us a value count. We can see that there is no house with only 1 room, and there are very few houses with 2 rooms and so on. Now you can also generate the percentage for this variable. Similarly, if I look at the n bathrooms variable, We have 78% houses with 1 bathroom and 21% with 2. Now, since we have a very less number of categories for these variables, it was very easy for us to look at the numbers and the percentages, but we can also look more intuitively by using plots in this case. So I can generate a bar plot for this variable. Let's do that. So I have the same variable n bathroom that we just saw and the value counts, which is the number of houses with bathroom 1 and 2. And I'm going to use dot plot here and specify the kind is equal to bar. This will give me a bar plot for this particular variable, right? So I have a bar plot here which indicates for the categories 1 and 2 how many houses have 1 bathroom and 2. Now let's take up a variable which has larger number of categories. So if you remember, the variable area had 17 different categories. Let's plot that. Now we can see that there is a very less frequency against these categories. And if you look closely, we have crumpet like almost 4 times, and looks like this is the correct spelling, and here are just some spelling errors. So this is something that we would again need to fix during the data manipulation part. And same goes for T Nagar. We don't have a space here, while in this case we have a space. So these are some of the access categories. Otherwise we have only 7 unique area names here, and we can see that the maximum number of houses are in the area Crumpet and followed by Karpakam. Right, so let's take up another categorical variable. I have a variable parking facility, which again has 2 categories, yes and no, and then again there's a spelling error. So let's see how many of the rows have this error. We have only 2 rows which have this spelling error, so we'll need to fix this during the data manipulation part. And what inference can we get from here is that the number of houses which have the parking facility is almost same as the number of houses which do not have the parking facility. So this distribution is almost the same. So as an exercise, you can go ahead and take up the other categorical variables that we have and generate similar plots for those. In the next video, we are going to work around with the data manipulation part, where we are going to fix these spelling errors and fix the data types of the variables, etc. I'll see you in the next video. Thank you.